Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is an analysis of a conversation on software design. This just popped into my feed, a conversation between Robert C. Martin, also known as Uncle Bob, and John Ousterhout. I hope that's his name. I'm going to call him John from now. Sorry if I mispronounce it. And what they did is very interesting. So Robert C. Martin wrote a few books, specifically Clean Code, but I associate him with the School of Software Design. His School of Software Design is mainly defined by clean code, solid principles, test-driven development. These are the practices that he has promoted, and he believes they fit well together. And I've seen many teams working really well with these practices once they manage to master them. But like any school of software design, one thing that's important to understand is that maybe we don't have as much in software development is that schools of design have limited applicability. If you go outside the software world and look at other other design disciplines, if you take industrial design, for example, there's a minimalist style of design. And then there's a reaction to that, which is a style of design that would have more ornaments and so on. So each of these styles have their advantages and disadvantages, and it's okay to have conversations and to try to figure out where each of these fit. And these two people did basically that. So we know Robert C. Martin, Uncle Bob, is more well known. And John wrote a book that I've heard really good things about called The Philosophy of Software Design. And they sat down, they say before September 2024 and February 2025, and exchanged emails and had some talks, video chats and stuff like that, and ended up with this document that describes, and is public available, and describes their similarities and their differences in how they see software design. And I think this is great. Now, I am giving Uncle Bob one thing here, that he has a coherent school. So the things that he's talking about, clean code, solid principles, test-driven development, they fit well together. They make sense together. And they come from the low level, how to structure your code, how to write your code, slightly higher level, how to structure your objects, classes, and so on. And then how to make sure that everything works and what's the method to get there. Now, this is why these things fit together. Now, I'm purposefully ignoring clean architecture. From my view, clean architecture is just another form of hexagonal architecture. And I think that is more interesting, at least to me. But many teams have had success with clean architecture, so more power to them. And that's where I kind of make a difference between the School of Architecture, the School of Software Design. Okay, so they discussed this, and I'm gonna skim through some of the things that they've said. First of all, it's the basic of philosophy. So John says, for me, the fundamental goal of software design is to make it easy to understand and modify the system. I use the term complexity to refer to things that make it hard to understand and modify a system. The most important contributors to complexity relate to information. How much information must the developer have in their head in order to carry out a task? How accessible and obvious is the information that the developer needs? And you cannot really disagree with this. although we already see a little bit of bias, right? And that's okay. When I say that we see bias, that's normal. And every school of design has their own strong principles and biases. And here what we see is a bias towards changeability. And in order to have changeability, and by the way, this is what Robert C. Martin wants as well, only he comes from a different perspective. But John treats changeability in terms of information, and I would rather, instead of information, I call it knowledge. It's more about knowledge. Because they hit a wall later on. And I think if you think about software development in terms of knowledge, you start to figure out why some things don't quite fit. But let me give you an example where this approach doesn't work that well. If you want to implement really performant algorithms, and I mean very performant algorithm, where you squeeze the maximum out of your processor and your computing capacity, this theory doesn't hold anymore, because you necessarily, in order to optimize something to the maximum, you necessarily need to know more, and you need to hold more information in your head. So while I agree with reducing the knowledge that you need at a certain point in time, we have to be aware of the bias. And the bias is this one. It fits for a certain type of product, and that's fine. Every method has an applicability domain. It doesn't have to be 100% working for absolutely everyone. And then Robert C. Martin says, I agree with your approach. A discipline or technique should make the job of programmers easier. So I would add that the programmer we want to help most is not the author. The programmer whose job we want to make easier is the programmer who must read and understand the code written by others or by themselves a week later. Programmers spend far more hours reading code than writing code, so the activity we want to ease is that of reading. Now, I know from other sources, from some previous conversations that Uncle Bob recorded as well, that he comes to design from the perspective of, I want to reduce the developer cycles. So I want to move more into computer cycles than we have in developer cycles. And then they go into a conversation about three main topics: method length, comments, and test-driven development. I'm gonna skip through this and just go to the conclusions. And the conclusions are quite interesting. So this is what they end up with. We agree that modular design is a good thing. I mean, everybody agrees. Although, once again, I've seen a specific design technique which is actually driven from the processor upwards. And this means that you might need to rewrite some parts of the code depending on the processors you are running on. Again, if you're trying to heavily optimize for one thing, other things will not work as well. So in that case, modular design, maybe not as helpful. But in general, modular design, and in the context of we want changeability, absolutely correct. We agree that it is possible to do over-decompose, and then ClickHouse First Edition doesn't provide much guidance on how to recognize over-decomposition. Yeah, that's correct. We disagree on how far to decompose. You recommend decomposing code into much smaller units than I do. This is written by John. So that's what I means John. You believe that the additional decomposition you recommend makes code easier to understand. I believe that it goes too far and actually makes code more difficult to understand. You believe that the one thing rule applied with judgment will lead to appropriate decompositions. I believe it lacks guardrails and will lead to over decomposition. Yeah, this is disputable. I've seen the examples that they give. The problem with the problem with design in general is that it's very hard to figure out how far to decompose. The one thing rule is something about coupling and cohesion, actually. You want to have things cohesive, what change together stays together, but it's quite difficult to figure it out. And the way I figured it out is by imagining what forces you need to apply in order for the code to change. And if you have a number of forces, then it's one thing, but it's really a judgment. It's really a judgment call. And a lot of these conversations about design, I think they miss on one thing. You need to build an intuition for software design before you are able to design. And the way design schools outside software do that is by making designers, people who want to become designers, go through a number of exercises where they need to come with 4 or 7 or at least 3 different variants for the same object that they are designing. And we don't do this enough in software, because you build your design intuition by seeing examples. We agree that the internal decomposition of prime generator into methods is problematic. Okay, so this was an example from the book. Entanglement between methods in a class doesn't bother you as much as it bothers me. You believe that the benefit of decomposing methods can compensate for problems caused by entanglement. I believe they can. When decomposed methods are entangled, they are harder to read than if they were not decomposed. You believe that ordering the methods in a class can help you compensate for entanglement between methods. I don't. Okay, and just quickly, let's see if I can find what entanglement is to clarify this. Entanglement is basically, the way I see it, it's a form of connaissance, which doesn't explain it. Two methods are entangled or conjoined in philosophy of software design terminology if, in order to understand how one of them works internally, you also need to read the code of the other. Now, I do have a problem with this, because to me the problem is in the level of abstraction. Imagine you are reading an article and you felt the need, and the article has links to other sources, right? So you read through that and say, okay, so that person, whatever, Uncle Bob said, and there's a link on Uncle Bob. And you feel the need to click on Uncle Bob to read everything about him and then go back and so on. So I think this makes sense if the level of abstraction is wrong. You might need to switch between methods if you want to understand what the whole thing is doing, but only if that method is not properly named, is not very obvious what it does from its name and how it's called. And the second thing is, it's not at the right level of abstraction, because if it's not at the right level of abstraction, then obviously you need to move through these methods. But most of the time when I write code, I don't need to do that. It's much like writing a text. You split a text into sections or chapters, or sub-chapters, and then each sub-chapter has a title, and then it has paragraphs, and each paragraphs communicates an idea, and so on. So there's all these things that can happen in the code as well, and I don't feel the need necessarily to go and read the full code once I have the list of calls. That is really a problem of level of abstraction. And the second thing is, it's also a matter of how you write your code. The more you constrain your code, the less you'll feel the need to read through it. For example, they hit into this, I think, later in the comment section. But basically, if your functions are mutable, if your functions modify the state of objects and so on, then yeah, you have more side effects. You need to go look into those and so on. But if most of your functions are pure, are immutable, then there's no need for that. Because if you know what they are doing, and if you know based on the name, you know what they are doing, and you see that name part of your overall structure of a higher level function, doesn't matter. It's like skipping the links in an article. So these are a few of my comments. I think they are getting into some topics while brushing a few things over, but not going really into the whole detail. But it's still a very valuable conversation. Okay, second thing, comments, John. Let's move on to the second area of disagreement. Comments. In my opinion, the clean code approach to commenting results in code with inadequate communication, which increases the cost of software development. And basically, what clean code is saying is that you should replace comments with code as much as possible, because comments can get outdated, while code is the thing that is more verified, is the thing that you build, that you test, that you run in production, that you optimize, that you review. And it's really useful to have comments sometimes, but it's very unhelpful to have comments that are outdated. So let's see what they say about this and how they disagree. John says clean code focuses a lot more on the evil aspects of comments than the necessary aspects. And that's fair enough, because there are a few sentences about good comments and then bad comments. But if you want to learn more, by the way, we have a really nice clean code course where you can discuss this in a lot more details. Okay, so let's see. Once again, I'm going to skip to the summary. Once again, John is making the summary. Our overall views of comments are fundamentally different. I see more value in comments that you do, and I believe that they play a fundamentally irreplaceable role in system design. You agree there are places where comments are necessary, but the comments don't always make it easier to understand code, so you see far fewer places where comments are needed. I would probably write 5 to 10 times more lines of comment for a given piece of code that you would. I believe that missing comments are a much greater cause of lost productivity than erroneous or unhelpful comments. You believe that comments are net negative as generally practiced, but comments cost more time than good comments save. You view it as problematic that comments are written in English rather than a programming language. I don't see this as particularly problematic, and I think that in many cases English works better. You recommend that developers should take information that I will represent as comments and recast it into code if at all possible. One example of this is super long method names. I believe that super long names are awkward and hard to understand, and that it would be better to use shorter names supplemented with comments. I believe that it is not possible to define interfaces and create abstractions without a lot of comments. You agree for public APIs, but see little need to comment interfaces that are internal to the team. You are unwilling to trust comments until you have read code to verify them. I think this is the largest difference between them. You are unwilling to trust comments until you have read code to verify them. I generally trust comments. By doing so, I don't need to read as much code as you do. You think this exposes me to too much risk. We agree that implementation code only needs comments when the code is non-obvious. Although neither of us argues for a large number of implementation comments, I'm more likely to see value in them than you do. Yeah. So, and I think this comes, once again, you can see the biases. So if you look at the source code written by Microsoft, for example, I've seen, because they provided the .NET framework code, so you could look through at least some of it. And before that, it was MFC, Microsoft Foundation classes. All that code was really well commented, and they had a very good discipline at writing comments, maintaining comments, and so on. But I'm sure, looking at it shows that there was a discipline there, and they were really careful about that. Whereas in the majority of corporate environments where I've seen code, comments tend to get outdated. People don't read them, they change the code, they comment code instead of deleting it. So it's a whole lot of bad practice that I see related to comments. So I think the constraint to have fewer comments and be more careful with your code is a valid constraint. It can really help improve some types of code. But now if you work in a team where you have a really good discipline of writing comments and maintaining them and so on, absolutely fine. That's great. So to me, I think these are two applicability domains. They are not actually arguing about the practice of comments. They are more like arguing about, this is my bias, this is your bias. So we have two applicability domains, and we need to differentiate between them. We need to pay attention to the context. And I think that's one of my biggest problem with conversations around software design. They need to take people into account. It's a socio-technical system. It's about the social part, it's about the technical part. People matter in software design until AI will do it for us, which I think it will take some time now. So yeah, I think this is what they are discussing. Okay, so they rewrite this thing, and now it's very interesting. They have a bunch of code. Okay, and then they move to test-driven development. Let's move on to a third area of disagreement, which is test-driven development. I'm a huge fan of unit testing. Once again, John is saying that. I believe that unit tests are an indispensable part of the software development process and pay for themselves over and over. I think we agree on this. Yeah. And you should write unit tests. If you don't, do. We have a unit test learning program, by the way, if you want to learn how to do this effectively and with modern techniques. However, I'm not a fan of test-driven development, which dictates that tests must be written before code and the code must be written and tested in tiny increments. This approach had serious problems without any compensating advantages that I've been able to identify. Well, and to me, once again, a matter of applicability, of domain of applicability. What programmers are we talking about? I think the personality of the programmer makes a lot of difference here. For example, one of the things that attracts me to test-driven development is the discovery aspect. The fact that I can write a test, focus on a small problem, and discover how to solve the problem that I'm trying to deal with in the process. But I am also able to look into the details and zoom out at the same time, because I came into test-driven development with an intuition for design. If you don't have an intuition for design, I think all the rest becomes kind of moot. It doesn't really matter which method you are using. However, test-driven development can be used to create this design intuition, because with TDD, if you apply it in a specific way, trying to generate a bunch of different approaches, the cutaway. So you take a small problem, solve it with test-driven development, but change the approach every day and do this for a number of days. You see a lot more different examples of design, and those build your design intuition. It's the equivalent of designing 5 versions of a chair in an industrial design school. And I think we are missing that. We are missing that factor. It's important to have that. So Uncle Bob comes back and says, okay, what you describe, John, what you describe as test-driven development in your book is wrong, and they correct it. What he is talking about, he has an alternative. Okay. The approach I prefer is one where the developer works in somewhat larger units than in TDD, perhaps a few methods or a class. The developer first writes some code, anywhere from a few tens of lines to a few hundred lines, then writes unit tests for that code. As with TDD, the code isn't considered to be working until it has comprehensive unit tests. And this is, Uncle Bob proposes that they call this technique bundling. I don't like this term. It doesn't tell me much. To me, it's a form of incremental test after programming, which is good. It's a limited, you take a limited part of the code and you write tests for it. And honestly, if that works for you, that's fine. It's as long as you are disciplined in doing it. But honestly, I don't see the difference that much. I mean, let me jump to the conclusions, and I think the conclusions basically say that it depends on the people using it. So let's see summary. John, we agree that unit tests are an essential element in software development. They allow developers to make significant changes to a system without fear of breaking something. Yeah. And I think one of the things that is really misunderstood about unit tests and the good test suite, it's not only that you have test coverage that allows you to test faster, that allows you to make changes easier, but it's the psychological safety of people knowing that they are building on solid ground. This thing, I feel, is often understated in conversations about unit testing. This level of psychological safety, if you know you have an excellent test suite, if you know that any change you make that might break the system will be pointed out to you in a matter of minutes, this is the one thing that can enable you and free you to develop software faster. And that's really great. We agree that it is possible to use TDD to produce systems with good design. Yeah. I believe that TDD discourages good design and can easily lead to very bad code. You do not believe that TDD discourages good design and don't see much of a risk of bad code. I think this really is again, it's a problem of the people using it. Do those people have an intuition for design? If not, they will hit the same problems with TDD and without TDD. If they use TDD in a specific way with katas and so on, they can build an intuition for design that they can later apply into both methods. So I believe that there are better approaches than TDD for producing good unit test suites, such as the bundling approach discussed above. You agree that bundling can produce outcomes just as good as TDD, but think it may lead to somewhat less test coverage. Yeah, it's a risk, but honestly, it's all about discipline. I believe that TDD and bundling have similar best case outcomes, yes, but that the average and worst case outcomes will be much worse for TDD. No. I mean, again, it depends a lot on the people. If I take some developers who know very little about software design, they will write really bad code and then test it. Maybe even generate tests for it with AI, right? And that's what bundling can lead to. So is that good design? Yeah. You disagree and believe that, if anything, TDD may produce marginally better outcomes than bundling. You also think that preference and personality are larger factors in making the choice between the two. Yeah. Yes. Yes. Okay. And then they have some closing remarks. But I'm gonna stop here about the article, and I want to go back. Anyway, you have it in the description so you can read through it. I highly encourage you to do so. But let me go back to some of the important points on the nature of conversations related to software design. So first of all, I like to define what I mean by software design. I mean structuring the code such that we optimize for desirable characteristics and then focusing on that. I think design is about focus, is about attention, is about care. And you can apply attention and care once you have a purpose, and the purpose needs to be well defined. I think this is what we are missing often in our conversations. One of the most common purposes we can have is changeability, right? We want to be able to change the code. After all, this is what software is. Software is about, it's soft. We can change it easier than we can change hard things like hardware. So that's what we are talking about. But then let's talk a bit about another aspect. Let's say we want to do performance. And we say, okay, performance is an important factor for our design. Fine. We have to define how far we need to go with performance. Is it okay if you have a second delay for, let's say, the main parts of your product? Or do you need milliseconds? So maybe you need 1 millisecond delay is a problem. Maybe 1 microsecond delay is a problem. Maybe 1 nanosecond delay is a problem. Maybe 1 picosecond delay is a problem. All these are completely different levels of performance. You'd write code very differently if you need picosecond performance, whether if you need second performance. It's miles away. It's really far. It's not the same thing. So in one case, you might need to write code that takes care of all the CPU cache hits and misses. In another case, you just don't care. You write, well, you care, but not that much. So this is where these things come into place. Now, what other characteristics can we talk about? Uncle Bob uses his bias and optimization for programmer cycles. We want fewer programmer cycles. We want to move more into the computer. So this means that the things you can automate, you move to the computer. And then you kind of try to go into a way of thinking that helps the programmer apply attention for a longer period of time. One of the good things about test-driven development is that because you are working in such small steps, and because the computer is doing a lot of the work for you, and because the computer is also telling you if things are, you get a red light or a green light, so you know whether you're on the right track or on the wrong track. You have a feeling of progression. If you keep progressing, you can get into a flow state, and that optimizes programmer cycles. Again, one of the things that's not that obvious, because you are spending less of your time worrying, less of your brain cycles, let's say, worrying about what might happen. You know you're building on solid ground. You know what is the next step. You know it's a small one. You know if you make a mistake, you can always go back 5 minutes ago, and it's still fine. So this is a powerful technique, and that's one of the reasons why. John goes more on reducing complexity, and later on he talks about optimizing for the first read as a proxy for reducing complexity. And this is very interesting because we get into knowledge territory. But I think one of the things they stuck at is the tacit knowledge. If you have a stable team of 7 people who work together for 7 years, let's say, because it sounds good, they will know the ins and outs of their system, and they can discuss between themselves and remember things they've forgotten and so on. So there's a lot of tacit knowledge there. Even if you try to write more comments, the tacit knowledge will not translate correctly. First of all, it's very difficult. It's something called the curse of knowledge. Once you know something, it's almost impossible to imagine somebody else not knowing it. So when you try to explain things, you are bound for the curse of knowledge. You'll write comments that assume unconsciously that the other people will understand because they have a certain piece of knowledge that they actually don't. And in this case, they are actually, at some point, John is writing some comments, trying to describe the behavior of some method, and uses words that are meaningless to people doing the first read unless they have been intimate with that problem. So it's very hard to transmit in comments because of this. However, if you have teams that change often, then it makes sense to have this kind of approach where you optimize for first read, because you'll have new people coming, they need to understand what's in there, and so on. So to me, my hypothesis, which is not proven, okay, but I have a hypothesis that their differences is because their own of the teams they worked with or into. What are the other characteristics that you can consider? Well, I wrote a whole book on usable software design, which is taking this software design and saying software design is used by programmers because programmers come and interact with it. Now, the way they interact with software design is by changing it, which is different from, if you design an iPhone, but it's still a designed system. And then I took principles from usability. And I said, okay, what can we take from usability? And I will mention 2 of them which are important: learnability and reducing errors. So learnability is how fast a new person can integrate into the team, or how fast can you remember what you've done um, 6 months ago. And the thing is, learnability is not only first optimized for first read. It needs to be a bit more. Because what I'd really want is for the programmer to be able to interact with the system and learn a little bit about the system in doing that. It's through this interaction. So you can optimize for that. Particularly if you have, if you're changing people in teams very often. Reducing errors is another one. How do you reduce the number of bugs? Well, you might do root cause analysis. There are a bunch of ways you can deal with it. So do we care enough to pay attention to this? It depends. What kind of software are you building? Is a software where errors are very expensive, or is a software where errors are kind of fine, kind of okay? Now look, I worked for a while in outsourcing companies where bugs were just another thing to negotiate with the client. So yeah, I know organizations who made quite a lot of money from bugs. In that case, maybe. Okay, they don't have to be obvious, but you still have a lot of wiggle room there. And by the way, I didn't like those organizations. So, another thing that we need to pay attention to is we have the goals and we know what to focus on, which would be already great. I believe most teams don't have this very clear. The next thing is, okay, we are within a specific socio-technical context. Which techniques fit us best? Because each technique has a level of domain of applicability. I think John's bundling technique has a domain of applicability. Test-driven development has a domain of applicability, and so on. It's not, and this domain is socio-technical. It's about the people and about the technology. So, and this brings me to the last point, which is the biases. Each designer will have their own biases. This is true in general, and it's true for programmers who are basically designers. Yeah. They will have biases based on their context. And you can see the biases of these two people when they are discussing, right? I think a lot of the clashes are not because they disagree fundamentally, but because they come from different perspectives and with different biases. So to me, a really good way to think about software design would be figure out what are the desirable characteristics and where we need to pay attention. Understand your socio-technical context. Pick the techniques that fit and structure your code such that everything kind of works together. And that's how you get good software design. And with this being said, I hope you enjoyed this episode. I really love this conversation. I'm hoping for more conversation like this about software design. I think we need them. What do you think about all this? Do you prefer some of these techniques? Do you understand? Do you have more questions about software design that I could try to answer? Let us know in the comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.